Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So again, I'm going to quickly review factoring. We're looking for two numbers that multiply to be this last one and add to be this middle one. So the only two numbers that multiply to be 2 are 1 and 2. So x plus 1 times x plus 2. For the math knowledge question, we have a graph that intersects with y equals a and a quadratic. And we want to know where they intersect in exactly one spot. So where does a equal x squared minus 6x plus 8? So basically, we are going to try and figure out what our x value is for our vertex. And then we'll go from there to find our a. So if we factored this, we would want to put a plus 9 to complete the square so that we could factor it. Because half of 6 is 3 squared is 9. So if we add 9, we need to subtract 9 from this equation to make them balance out. And so x squared minus 6x plus 9 will factor as x minus 3 squared. And then 8 minus 9 is negative 1. So this is going to be the vertex, and we have a parabola, and the only time that a horizontal line is going to intersect it at one spot is going to be right down here at the vertex. And so when our x value is equal to 0, like when this whole term equals 0, that's going to be where we're at the vertex. So when this is 0, when this goes away, our a value is going to have to equal negative 1. And so that would be your answer for that one. Okay, so we're going to be looking at lesson 3 today. We're looking at Pythagorean theorem. We're going to look at triangle inequalities, similar polygons, and similar triangles. So Pythagorean theorem hopefully is going to be review. The triangle inequalities mostly should be review. Same thing with similar polygons and similar triangles. So looking at Pythagorean theorem, hopefully you know Pythagorean theorem, a squared plus b squared equals c squared. 9 is 3 squared, 16 is 4 squared. If you add those together, that equals 5 squared, which is 25. A and B are the sides of your triangle, and C is the hypotenuse. A and B can be interchanged. You can only use Pythagorean theorem on a right triangle, though. So only used on right triangles. If your a squared plus b squared is bigger than your c squared, you're going to have an acute triangle. And if it's smaller, then you're going to have an obtuse triangle. So here is what I like to think of. If you have one leg and another leg, and then you have your hypotenuse. You have your hypotenuse. That's a right triangle. But if this one gets bigger, this angle becomes an obtuse angle, and so this hypotenuse is going to have to stretch further. So if your hypotenuse is bigger, if c squared is bigger than the two legs, then you have an obtuse triangle. And then if this one got smaller, the angle gets smaller, well, your hypotenuse doesn't have to be quite as big. So if your c squared is less than the other two, you have an acute triangle. So I use my hands to do that. I make a right angle, and then I either make them closer together or further apart, kind of like an alligator mouth. And that's how I keep up with it. So these are called your Pythagorean inequalities because they're based on the Pythagorean theorem, but they're inequalities. The sum of the lengths of any two sides is always going to be greater than the length of the third side. And why is that? If you have a side length that is 2 and a side length that is 4, going from here to here is 6. And so these two are going to have to be bigger than 6 to actually pop out to make the triangle. If they equal 6, then it's just going to be a straight line right on top of each other, which doesn't make a triangle. So any two sides is always going to be greater than the length of the third side. Always. Okay? So let's look here. The lengths of the sides of a triangle are 7, 5, and 4. Is it right, acute, or obtuse? So we're going to pick the two smaller ones. 4 squared plus 5 squared. How does that relate to 7 squared? So that'd be 16 plus 25. How does that relate to 49? Well, 16 plus 25 is 41, and that is less than our hypotenuse. So our hypotenuse is bigger, so that means that we have an obtuse triangle. So that's how you can use your Pythagorean inequalities. Now we're going to look at some similar polygons. Most of this vocab should be reviewed from geometry. Congruent means they're the exact same shape and size. Similar means they're the exact same shape, but they're different sizes. So the angles are going to be congruent, but the side lengths are going to be in a proportion or in a ratio. They'll be proportional, but they won't be the same length. So in similar polygons, all the angles are congruent and your opposite sides are proportional. So these are some examples that are not polygons. The reason the first one and the second one are not polygons, the sides cross. If you have a polygon, your sides cannot cross. This next one has a curved side. It's not straight, so that's not a polygon. And then this last one is open. It's not closed. So all of those are examples that are not polygons. On a polygon, the number of vertices is going to be the same as the number of the sides. So your vertices and sides are always going to be the same number. We have equilateral and equiangular polygons. Equilateral is where all the sides are congruent. Equiangular is where all the angles are congruent. If you have a concave polygon, there's going to be a little indentation. It has a little caved in part. And then convex is where it does not have an indentation. Some books say convex polygons are figures that are not concave. So hopefully you're familiar with all of those. One way you can connect any point to another point, and if it goes outside of the polygon, then it means that it has to have a cave. It has to be concave. So not here, not here, but here, those, or maybe from here to here, those would go outside of the polygon. So that's why it's concave. But on these two, no matter which 2 points you connect, they'll always be inside. So that's why they're convex. Okay, so now we're going to move on to finding our side lengths on our figures. So for these, we're going to want to set up ratios. And you've got to make sure that you match up your sides correctly. So this angle is congruent to this angle, and the side that is opposite is 4 and y. So 4 over y. And then this angle and that angle are congruent because of the arc marks. So that means that x is going to have to be over 6. Make sure that if you start with the 4, the one on the left, that side length always needs to stay in the numerator. Don't start switching them back and forth. So 4x and then 5 is going to have to be in the numerator because those are all 3 side lengths on one figure. And then y, 6, and the other side length that is in proportion to the 5 is the 7. So now you can use your pick two ratios to solve for your x and your y. So if I pick these last two, I would have 7x equals 30. And so x would equal 30 over 7. And then if I solve for y, I'll have 5y equals 28. So y would equal 28 over 5. So that would be how you can find x and y. Hopefully you kind of remember doing that from a previous year in math. Same concept here. We're going to make our ratios. So the one that is opposite the right angle is the 7. And I'm going to go ahead and do x and y, just so I don't forget that those need to be on the top. You could put them all on the bottom. It doesn't matter. You just need to be consistent. Either all 3 on the top or all 3 on the bottom. And then the side that is going to be corresponding to it is the 10. So 7 over 10. For x, the side that is corresponding to x is going to be z. And then for y, the only other side left is 8. So we can use this ratio and this ratio to make our proportion. We would have 10y equals 56. And then if you divide by 10 and leave it as a fraction, you would get y equals 28 over 5. Okay, so that would be for y. Now we've got a little bit of a problem because we can't find x or z because they're both in this ratio here. So we need to go back to this triangle on the right. We can use Pythagorean theorem to find z because it's a right triangle. So if you get into trouble where you can't find it because you've got 2, go back to your figure and you missed finding one of them from the figure. So if you use Pythagorean theorem, you'll have 64 plus z squared equals 100. So z squared will equal 36. So z will equal 6. And so now we can plug z into that ratio. So we're going to have 7 over 10 equals x over 6. And then if you cross multiply, you'll get 10x equals 42. And so x would equal 21 over 5. So that would be your answer for those 3. Okay, we're going to look at another example. On this one, the figures are, one of them, they both share one angle. So if you need to draw the 2 triangles, you can. Hopefully you'll eventually get to where you don't need to draw them, but I'm going to go ahead and draw them just in case someone needs them. So for the little triangle, the side lengths are 6, 4, and A. For the big triangle, the side lengths are 10, because that's what 6 plus 4 is, C, and then A plus B. So if you set up your ratios, you will have 4 over C, 6 over 10, and A over A plus B. So if you cross multiply here, for C you'll get 6C equals 40. So when you simplify, C will be 20 over 3. Okay. Now over here, we can't solve for either A or B, but I'm going to go ahead and try and simplify this a little bit so that I have A and B in terms of each other. So 6A plus 6B would equal 10A. If you cross multiply, and then if you subtract this 6A, you would have 6B equals 4A. Okay, so we need to either find A or B to be able to find the other one. So if you come back over here and look at this triangle, we can use Pythagorean theorem to find A. So 6 squared plus 4 squared is equal to A squared. So 36 plus 16 equals A squared. 36 and 16 is 52. And then if you take the square root, if we want to simplify, we need to factor 52. And it factors as 4 and 13. and 4 factors as 2 and 2. So A is going to be, instead of the square root of 52, we would have 2 times 2 times 13. And since we're doing square roots, to pull anything out, we need a pair of them. So we can pull out this pair of 2's and put 1 2 on the outside. So our A value would be 2 square roots of 13. And then we can plug that in right here. So we have 6B equals 4, and then A is 2 square roots of 13. So we can divide by 6 to solve for B. And that gives me 8 square roots of 13 over 6. But this little 8 and this 6 reduced by 2. So if you divide by 2, you'll get 4 square roots of 13 over 3. So that's your B value. So that one ended up with some strange looking answers, and that's okay. Don't give me decimals on these. Give me radical answers and radicals in fractions. Don't put these into your calculator and get decimal numbers, okay? But that's the basic concept of those. Okay, we're going to look at one more. This is going to be using geometric mean, which you should have learned in geometry. Some of y'all hated it, some of y'all loved it, some of y'all remembered it, some of you never learned it. So I'm going to go over geometric mean. H is our geometric mean of 4 and 8. And so what that means, we can set up a ratio where H is here and here, and then 4 and 8 can go in either spot. And so H squared has to equal 32. And then you can take the square root of both sides. 32 factors as 4 and 8, which is 2 and 2, and 2 and 4, and 2 and 2. So instead of 32, we have 5 2's. We can pull out one pair of 2's here, and another pair of 2's here. So that would be putting 1 2 and another 2 on the outside. So our H value is going to be 2 times 2, 4 square roots of 2. So that would be how you find H using geometric mean. Now we're going to find A using geometric mean. So A is the geometric mean of the whole hypotenuse and the part of the hypotenuse that is closest to it. So when we set up our ratios, A is the geometric mean, the whole hypotenuse is 12, and the part that's closest to it is 4. So that's how that works. And so A squared equals 48. And then when you take the square root, 48 factors as 4 and 12, which is 2 and 2. 3 and 4, which is 2 and 2. So instead of 48, we could say 2, 2, 2, 2, and 3, which we can pull out 2 sets of 2's, so that would be 4 square root of 3. Okay, so that would be finding A. To find B, you would use the same concept as finding A. So why don't y'all try and set up that ratio real quick by yourself, and then unpause the video and I'll go over it. So B is going to be the geometric mean of the whole hypotenuse, which is 12, and the part of the hypotenuse that is next to it, which is 8. So when you cross multiply, B squared equals 96. And so 96 factors as 8 and 12, which is 2 and 4, and then 2 and 2, which is 3 and 4, and 2 and 2. So instead of 96, we would have 2, 2, 2, 2, 2, and 3. So we can pull out a pair of 2's and another pair of 2's to make a 4 in front, and then we're left with a 6 on the inside. So that's how B would be found. So those are used in geometric mean, which we covered in geometry. It was lesson 51, I believe. So if you want to go back to that and look at that lesson in the geometry book, you're more than welcome to. You definitely want to learn geometric mean because it makes it a lot easier to do these. Okay? So your homework is 1 through 30. So make sure that y'all do those tonight so we can go over any questions you have tomorrow.